Hello and welcome to week 5, lesson 3. In this lesson we will be estimating the line of best fit. So you will draw a line of fit in a scatter plot and you will estimate the equation for the line of fit using slope-intercept form y equals mx plus b. Before we begin, I want to review a little bit with correlation because that will help us draw our line of best fit. So in this first graph here, this is considered a strong positive correlation because it almost looks like a linear line that has a positive slope. It's going up in the positive direction. So while your x's are getting bigger, your y's are also increasing as well. So this is a very strong positive correlation. We would say this is very close to a correlation of 1.0. This middle one is also a positive correlation, but it's not quite as strong. It's still closer to 1 than it is closer to 0, but because we have some dots that fall outside of a line, if we were to draw a line, it's a kind of a moderate positive correlation, so we might consider this 0.5 instead of 1. And then if we have dots all over the place and we can't see a trend, we have no correlation. Down here we have a moderate negative correlation. So again, this is negative because if we were to draw a trend line, it would be a negative sloping line. So this is a moderate negative correlation. Again, moderate compared to strong, like this one in the middle. This one, the dots are very close to each other. It almost forms a line. So this one would be a -1, whereas this one might be a -0.5. And then our final graph here, this is a nonlinear, sometimes called a curvilinear, but it's a non-linear graph, right? If we were to draw a trend line, it would look more like a U here. So this would be a nonlinear relationship. Okay, let's move on and look at our first set of data in our first problem. Okay, so here we want to estimate the line of best fit. And what I've provided is a table. So what we've done is gone through and interviewed, it looks like 10 subjects, and we asked them their experience in years and what their income was in thousands. And we wanted to see if there was a correlation between how much experience you have at something and how much money you make. So we say income in thousands, but we've only written it as 20 instead of 20,000 just for simplicity's sake. And then what we've done is we've gone ahead and we've graphed years of experience here. So years of experience is our independent variable. And then we want to see if our income is a result of our years of experience. So we graphed our income on the y-axis. Okay, so for example, on this first subject who had 0 years of experience, he or she was just starting off. He or she's income was 20,000. So here's 0, and then right here's 0, and then we have a dot right there for $20,000. Okay, and then we've gone through and we've graphed all of those points. So we've graphed years of experience related to income. And what I've also done is already drawn in a line of best fit so that we could analyze it. How do you draw a line of best fit? Well, when we draw our line of best fit, we want to draw a line that takes into account an average of all the. The goal is not to necessarily go through as many dots as possible, but to make sure that the number of dots that we have above the line matches the number of dots we have below the line, as well as taking into account the distance the dot is away from the line. So it looks like here we have 1, 2, 3, 4 dots below the line. And in this top one, we have 1, 2, 3, 4, 5, one extra. But if you'll notice, the dots below the line are a little farther away, like this one right here. This is pretty far away from the line. Maybe this one is comparable. But then we have this one, which is fairly close, this one, which is fairly close, and we only have one that's that close on the other side of the line. So the goal again is to kind of take into account an average. So it won't be precise, but it will be an estimate of our line. The second thing we're going to do is once we have our line drawn, you guys know how to find the equation of a line. So remember that we're going to use slope-intercept form, which is y equals mx plus b. And we are going to find the equation of the line. We are not worried about these dots anymore. We just want to find the equation of the trend line so that we can make predictions in the future. Well, in order to do that, we need to come up with two dots somewhere on this line. They don't have to be dots that we plotted, they just have to be on the line somewhere. So, for example, I could take 20 right here, come up, and I can plot a point on the line right here. And that point looks like it hits 50. So we're going to call that point 20, 50. Okay, notice that's not one of the points that I plotted. However, that point is on the line, so it's a good point to use. Let's look for another point somewhere. Let's see, we could choose 10. We could come up here from about 10 and plot our point here. And that one looks like it splits the 30 and the 40 in two, so that's probably about 35. So the second point I'm going to use is 10, 35. And remember that I need to identify 2 points in order to write an equation of a line. So if we go back to what we've learned last quarter, our first step is to find the slope of the line. So let's do step 1. Let's go ahead and find the slope. Well, remember that the slope, which is our m, is equal to y2 minus y1 over x2 minus x1. So plugging that in, let's go ahead and label this as, we'll say this is x1 here below and y1 here. We'll call this top one x2, and over here we'll call that y2. So we'll take y2 minus y1, so that's 50, minus 35, and we'll divide that by x2, which is 20, minus x1, which is 10. We get 15 over 10 for our slope. Now we could reduce that. 5 goes into 15 3 times, and 5 goes into 10 2 times. So now we have our slope. Our slope is rise of 3, run of 2. So if we are taking step 2 means we are going to plug in a point into our equation. Okay, so that means we need to pick a y and we need to pick an x and plug it into this equation for y and x. We already know m is 3 over 2. So let's go ahead and pick 10 and 35 and plug that in. So here we go with step 2. I'm going to put 35 in here for y, and that equals m, which is 3 over 2, and we're going to plug a 10 in for x plus b. And now we're going to solve this for b. So we have 35 is equal to, well, 10 is the same as 10 over 1, and when we multiply fractions, we just multiply straight across. So we get 30 over 2 plus b. Then we can simplify 30 over 2 to give us 15 plus b. If we subtract 15 from both sides, we'll find our b. 35 minus 15 is 20. So b is 20. Now for step 3, we have enough information to write the equation of our trend line. So now we're just going to write the equation. And the equation is y equals 3 halves, that was our slope, x, plus 20. So from that we can make predictions. We can make predictions about the future. What happens if you have 40 years of experience? How much can you be predicted to earn? And we would plug 40 in for x and then we could solve. So let's try one prediction. So let's do that. This graph doesn't go to 40. We can look at the graph and maybe kind of guess, but it doesn't go to 40. So let's actually use our equation to help us. So let's just say we have 40 years of experience. And we want to know how much we would make. Well, Y is going to be the total income. So X is the years of experience. We plug 40 in there, and we can figure this out. 40 is the same as 40 over 1. So 40 times 3 is 120, and 2 times 1 is 2. If we simplify this, 120 divided by 2 will give us 60, and 60 plus 20 is equal to 80. So $80,000 is what we can be predicted to earn if we have 40 years of experience. All right, let's go back up to our graph here. If I say 40 is about right here, and I just kind of go up, and we assume that this trend line continues, you can see that right about here would approximately be 80,000. So you can see it on the graph as well. All right, let's try a couple more quick examples just so that you can see it done with some other graphs. In this example, we have beach visitors. So we have the average daily temperature as our independent variable, and then we have the number of visitors as our dependent variable. And we want to determine if there is a correlation and what it would be between the temperature and the number of visitors that come to the beach. So the first thing we have to do is see if we can draw a line of best fit. So I'm looking at these dots, and I would say they are moderately correlated in the positive direction. So I would want to draw my line of best fit somewhere, again, remember to take into account an average. And again, everybody will be slightly different because we're just making an estimate and not actually calculating. So that would be my line. It looks like I have 1, 2, 3, 4, 5 on this side and 1, 2, 3, 4 on this side, but underneath the line those dots are a little farther away. And then I have 2 dots which appear to be exactly on the line. So that's my line of best fit. We have a positive correlation, maybe of 0.5. Not quite a perfect correlation of 1, but moderately. Okay, so let's go to our steps. So our first step, remember we need to locate a set of points in order to find the slope. So let's go ahead and actually take these 2 points because they are on the line. So here we have 82 and 80, let's say. So we've got 82 on the x and 80 on the y. And then this point right here is 94, 600. And I'm going to use those points in order to do step 1, which is find the slope. So our slope, I'm going to name these dots. So we need to do an x2, y2, and a y1, x1. So there I've named my points. And now I'm going to find the slope. So we would do 600 minus 80. Those are the difference of my y's. Over 94 minus 82, which is the difference of my x's. So I went ahead and subtracted, and then I divided this fraction into 43.3, and that's certainly fine versus reducing the fraction. So let's go ahead and do step 2. And step 2, remember, is we need to take one of our points and plug it back in. So let's go ahead and pick 94 and 600. Those are big numbers, but I like those numbers. So let's try that. Let's plug those points in. And now we've plugged in the points, so our 600 replaces y, and our 94 replaces x, and here's our slope. Now we just need to simplify this by multiplying the 43.3 times the 94. And when we multiply those, we get 4,070.2, and then if we subtract 4,070.2 from each side, and I've done that here with the calculator, we get a negative y-intercept of 3470.2. So our final step is to write our equation, and then we can use that to interpret things in the future. So our final equation is y equals 43.3x minus 3470.2. Now obviously if we were to analyze this and look at this trend line, perhaps it would go below zero, but again remember that our trend line is merely an estimate. So if we had an average daily temperature of 0, we're assuming that we would have a negative number of people, which doesn't exactly make sense, but again this is an estimated trend line. So if we wanted to predict what if the temperature was 100, we could plug 100 in here and determine how many visitors that we would have in the future. All right, let's do one final example. In this example, again, you are given data. You are given the sales figures versus the advertising dollars. So we want to determine if the more we spend in advertising, the more sales we might get. So we would plot our data, as is done here for you, and then we would draw in a trend line. This time I'm going to draw it all the way to the y-axis. And it looks like maybe right in there. So I've got 1, 2, 3, 4, 5, 6 on this side, and 1, 2, 3, 4, 5, 6 on this side. So we've split the data into 2 equal parts. All right, let's go ahead and start our steps. So let's start step 1. And to do that, again, we need 2 points on the line. I don't see any of these points on the line, so I'm going to have to come up with my own points. And it looks like I could maybe choose, if I come up here and I choose a point here at 6, it's really close to that purple point, but not exactly. That looks like about 111. So we'll give it a 6 and a 111. That'll be one of my points. And then I'm going to choose another point. Maybe I'll choose, and I want to try to choose points that are going to be easy for me to play with as far as subtracting and adding. So I think what I'm going to do here with my trend line is make it a little bit longer, and then I'm going to choose a point that's on 7. So if I come up here and choose 7, it looks like sales are about 124. So I'm going to choose 7 and 124. It's also good to get points that are spread out a little bit just to ensure that you have a good slope. Okay, so now we'll go ahead and find our x1, y1, x2, y2, so we can mark these, x1, y1, x2, y2, and then let's do the slope. So here we have 124 minus 111, 7 minus 6, which gives us 13 over 1, which is just 13. Step 2 is pick a point and plug it in. I'll go ahead and pick the first point this time. So we'll plug in 111 for y. We'll plug in 13 for m and 6 for x, and we'll find b. I'll multiply those and get 78. Then I'll subtract the 78 from both sides, so 111 minus 78. Subtracting the 78, I get 33, so b is 33. And our final step is just, again, to write our equation of our trend line. So it's y equals 13x plus 33. And again, if you'll notice, this isn't 33, the y-intercept, so either I would want to go back and double check my work, or understand that this is a trend line and it's just an estimate and it may or may not be to scale. And again, the purpose of our trend line here, this y equals 13x plus 33, is to be able to make predictions about future spending or future amounts. So if, for example, I was planning on spending in the thousands, 10 of advertising dollars, I could predict potentially what my sales are. And that's how we do a lot of predictions in life with the stock market and other things like that. So that concludes our lesson, and hopefully today you now understand how to draw a line of fit and how to estimate the equation for the line of fit.